Okay, so good evening, everyone, and let us start today's session. And let me just check whether I'm audible or not. I think we can continue. Yes. Okay, so I'm audible now. So I think we can continue. Okay. So as you know, this is a part of Foru 5 series, and today I'm going to discuss some of the questions from the mechanical engineering portion, that too specifically from the industrial engineering section. Okay, so let's go ahead and discuss some of those questions which are going to be quite important from the exam point of view, particularly the concept part. Okay, so let's go ahead. And here's the first question for you, and this question is from the inventory section. Okay, so broadly, if you say, then broadly 3 areas will be covered today: inventory, and then you're having forecasting, and maybe break-even analysis, etc. So those will be the areas from where we are going to discuss some of the questions. Okay, so please go through this question and try to answer it or solve it within 1.5 to 2 minutes. Okay, maximum 2 minutes should be a target. So in the meantime, let me just write the information also. Okay, first of all, you need to decide which model is this, right? So see, whenever you're having production rate and consumption rate, these things have been given to you, then definitely it is a finite production that model, that is finite production rate model, where simultaneously you are having production as well as the consumption, right? So if you see over here, he has given you the manufacturer received an order of 8,000 bearings per day from the customer. Holding and all that has been given to you. Setup cost has also been given to you. But at the same time, he has also given you the what? Production rate is also given him. A manufacturer can produce 12,000 bearings per day. That means he has given you the production rate also. In the first model, as you know, is the simple economic order quantity model. In that model, basically production rate is infinite. So he is not going to mention about the production rate. So if he has talked about the production rate, then you have to make use of that particular model. So can I write this way? Okay, he has written manufacturer can produce 12,000 bearings per day. So that is production rate. If I want to write that, I will write it with P. That is how much he has given you. which is equal to 12,000 bearings per day. Okay. The manufacturer received an order of 8,000 bearings per day. Now, he has a 8,000 bearings per day. It means it is a consumption rate. Every day, how many bearings are getting consumed? That is what he has given you. So that means consumption rate is 8,000 bearings per day. Right? So it means, as you know, in this model, production rate has to be more than consumption rate. It will be more than consumption rate, and that is why then only the inventory can build up. So, and from consumption rate also, I can find out the annual demand. If I say that how much annual demand or how much bearings are getting consumed in a year, so that becomes the annual demand. So that you can find out from where. If you know the consumption rate per day, and if you multiply by the number of days, then obviously job is done. You will find out the annual demand. But at the same time, he has mentioned very clearly over here how many days you have to take as a working day. That is 300 working days. That means total annual demand is going to be consumption per day multiplied by number of days in a year, and more specifically over here the working days in the year. So can I say the annual demand, which we denote normally with the help of D, because this is a deterministic model, then we know the demand in actual demand is how much is the actual demand in a year, that we know. So that means I can write it this way: 8,000 multiplied by what? 300. So this becomes these many units in a year. That's all. Rest information has also been provided to you. That means this is the model you know very well. So this is the model that we are talking about. So where you are having a particular, right? So I can write this way. Right? So this is the quantity that you are talking about, and this is the, you can say, time, right, that we talk about. So when we have this situation, and now if I ask you what is this, you will say this will be the quantity ordered. Each time the quantity that you are ordering, this becomes that much in this particular model. And how much inventory build up take place? You say maximum inventory that can take in build up that can take place is this much. That is corresponding to this much. This is the order quantity that you have ordered, and this is the cycle time. You know, here you have you can say this is the production time, we say this is procurement time, and we say consumption, we say depletion time, we denote with D, TD, and total cycle time, we say this is one cycle. Then the same cycle is repeated as we move further. And now what he has asked you to calculate, he is asking us to find out the frequency of the production run should be how much. Frequency of the production of this term should be clear to you. Frequency of the production run means the cycle time basically he's talking about. So how you can find out the cycle time? That formula you already know. So cycle time that we find out is basically we will say T is equal to what? The number of orders that is placed per day, or number of orders that are placed in a given period, that is the per annually. Or you can also say, you can write in terms of what? In terms of, because how many number of orders you will place, right? That will depend upon what is the annual demand. If you will divide it with the quantity that you are ordering each year or each time. That means, let us say annually you are annual demand is 12,000 units, and each time you are placing 1,000 units as an order. Then how many orders you place in a year? You will say 12 orders you placed in a year. So that way, if you want to find out the time, that means the cycle time, that means the time between placing the orders, time between two consecutive orders that you place. So that you can find out by time between two consecutive orders is 1 divided by the number of orders that you have placed in a particular period of time. So from here I can find out the, so either you find it separately, or you put that value over here, that it will be D by Q. So it will become Q by D. Now this is in general, I am writing this formula, but you know, when he has given you the information, we need to find out the quantity which we call as a economic order quantity, because you don't know how much quantity you are ordering each time. Do you know? No information is provided how much quantity you are ordering each time. So, and if you don't know, then you need to find out the quantity which will minimize the total cost, and that quantity we call as a economic order quantity. So what I need to do, I need to find out the quantity which will minimize the total cost. We call that as a economic order quantity. We will denote it with the EOQ. We call it as a EOQ, and we denote it with the Q star. So if this is the quantity that I am ordering each time, then number of orders that I am going to place will be the annual demand divided by the quantity that I am ordering each time. So that means over here, then I'm going to write, instead of Q, I'm going to write it as a Q star, because this is the quantity that I am ordering each time. And since this is the economic order quantity which is going to optimize the or reduce the total cost, it means the time, cycle time corresponding to that quantity will be the, I will call optimum cycle time, or you can say the usko humne naam diya frequency of production run, which will correspond to this. So that means how much is that? This is this total time. This is the cycle time T. I can denote it. But when I represent the same cycle time corresponding to the quantity, which is Q star, then I will denote it with the T star. So I hope you have now got it, which you may be remembering. But anyway, I'm going to write it this way also. You can write it so that it becomes pretty easy for you to understand. That is the frequency of production run. That means time, optimum time between the, we also call it as a optimum time between two orders. One order I placed over here, then a second order which I placed was over here. So I can also call this time cycle time. I can call it as the optimum cycle time also, or I can also call it as a frequency of production run. So optimum frequency of production run, that way also I can call it. So that is a cycle time only. So I can write that way also, production plus TD. This becomes the star, which is become equal to what? I wrote it as Q1 by N. We say N star, that is the optimum number of orders that I need to place. So that becomes Q star by annual demand. That is all. So this is what you know. Now what I need to find out? I need to find out the, what is that economic order quantity over here. So for that, finding out the economic order quantity, which is, so EOQ is equal to, which we are calling it as a Q star, is equal to what? So in this case, you have the formula 2dc0 divided by cc, and all these terms should be clear to you. 1 minus consumption rate divided by the production rate is the under root. For the simple economic order quantity model, you are having the formula of finding out the economic order quantity, this one. This is the, because in that case we don't have consumption rate and production rate, right? So we have simply, so in this formula you just add this lower term, and this becomes the economic order quantity for the this particular model, right? You have, so now do I have that consumption rate? I know. Production rate I know. Ordering cost I know, because he may have given the cost of holding. I think setup cost per production run is this much, right? So as you know, since the manufacturer is producing the bearings at his own end, so he is producing at this rate, and basically it is dispatching 8,000 bearings per day. So how much is left out? So that means 4,000 is getting left out at his end. So since he's that means he's producing at his own end, and maybe he's consuming at his in his plant only. So in that case, we use the term called as setup cost, but that setup cost is the ordering cost only. So can I say that ordering cost he has given over here is the rupees 500 per order. So to place each order, so setup cost. So when we place the order to outside entity, then we say it is a order cost per order. When the same thing is done within the organization and it is consumed at your own end, then we call it as a setup cost, and this turns out to be this much. And what is the carrying cost? The cost of holding a bearing in stock is rupees 0.2 per month. But you know, since you have to, so I want the carrying cost. So carrying cost, as you know how it is represented, rupees per unit time. So to hold that quantity for a certain duration of time, how much you have to spend. So in this case, since this is per month, I can convert it into year also. So this becomes the 0.2 into how much? 12. So 12 months in a year. So this becomes rupees, this much rupees per unit per year. That means to carry 1 year unit as an inventory for whole year, how much you have to spend? You have to spend 2.4 rupees. That is the meaning of this. All these things you know now. Simply you need to input the values, and therefore the only thing that you have to take note of over here is that the units, consumption rate and production rate units should be same. D, that will depend upon you, because if demand you are taking annual demand, which I have taken over here is annual demand, units per year. In that case, carrying cost you have to take rupees per unit per year basis. If you are taking demand on monthly basis, then you have to carrying cost you have to take in this on the monthly basis. So since I have already converted the demand into an annual basis, so that is why I have converted this carrying cost in the annual basis only. So now input the values. So you're going to have 2 into what is the demand, annual demand you are having. So it becomes 8,000 into 3,300, sorry. And what is order cost per, that is the, which is setup cost also, divided by carrying cost is how much? This is 2.4, that is 12 multiplied by 0.2. And over there, these units should be same since they are being represented a bearing per day, and over here also per day basis. So I can say this is what is the consumption rate? 8,000 divided by production rate is 12,000. This one, and you're going to get this value. And how much is the economic order quantity? From here you can get it. And I think these number of units that you're having, that is economic order quantity Q star is equal to 54799.66 units. This becomes the, so that means this is the quantity which I will place as an order each time. This is going to reduce my total cost, optimize my cost. Total cost will get minimized. That is total inventory carrying cost, which we talk about. That is combined to order cost plus holding cost, that will be minimized. This much quantity I need to order each time. That means this quantity, which this is the order quantity that I need to place now, is be this much quantity. So this will become, instead of Q, I will denote it as Q star. And in this model, you know, this is production rate. Slope of the this represent the production rate. So if you want to write it, this is the production rate, which we denote P, 12,000 bearings per day. This is consumption rate. Consumption rate is have not been shown on this side. If you have clarity on this particular model, even though you know every day, because from the very start, every day something is getting consumed. So, but this line is not the consumption rate. This line that represent over here is what is left out. That means 12,000 bearings you are producing, production rate, and consumption rate is also going on over here, which I have not shown on this side from this line onwards. So that is 8,000. So that is 12,000 minus 8,000. We call it as a inventory build-up rate. So I can represent it as a P minus C dash. That is this slope that we are representing. This is basically the inventory build-up rate. How much inventory every day is getting built up at your end. So that will be, you can say 12,000 minus 8,000, that is 4,000 bearings per day are getting saved at my end, and that is represented by this line. And rest you may be knowing about this model. I don't need to explain in detail. So rest, I want to find out T star, cycle time when I'm Q. So cycle time T, corresponding to quantity Q. So since now I am Q star, so this time will become T star, which we are calling as a frequency of production run. So we are having T star equal to how much? So Q by D. So 79966 divided by, now demand, since I have in units in 8,000 into 300, this is in year. So units per year. So either you convert it into units per month, units per day, because he's asking you to calculate. He has given you most of the information. Either you can get it converted into month or maybe in day. So let me just convert it into day. I can convert it into day by dividing by 300, because this is annual. or you can simply say 8,000 was already per day only. So I can either you write it in per day, or if you have taken this information in annual, then you need to divide it with the help of 300 working days. So that is 300. Meaning is same. So now this information that I'm going to get will be now in days. That how much will be this cycle time, that is in days, and this information turns out to be 6.85 days. Okay, so that way. So that is how you have to attempt this question. So I think there is very high probability इस particular model में से normally if you don't have clarity on this model, particularly इसको थोड़ा सा समझ लो, फिर directly formulas का use कर सकते हो, whatever that you are having. Normally you have confusion in this understanding this model. If this model is clear to you, what is the meaning of this line, what is the meaning of this line, what is this, how you can represent in terms of consumption and all that, then I think it is pretty easy. Let us now move on to the next question. Please go through it and try to solve it. Okay, I think visible नहीं है आपको बहुत clearly. Let me just check it. Just a moment. Okay, let me just read it to you. Okay, and I will write this information. Basically he's saying demand for the past 4 years is given below. यहाँ पर data दिया है 4 years के लिए. Calculate the forecast for the 5th year. So you are having this one. I will erase it. I am writing it year and demand. Okay, so 1, 2, 3, 4, 5. This is how you have been given, and he has given you the demand 100, 150, 250, and he's asking you to calculate the demand for this particular 5th period. And he's also saying that forecast for the first period is how much he has given you equal to the demand, that is 200. This information is given to you, and he's saying that use the exponential smoothing constant at 0.5. Okay, so that is exponential. ये और ये data आपको दिया गया है. Demand data has been given to you. Forecast for the first period only given. You are supposed to find out the forecast for the 5th period. कि इस period के लिए आपका forecast क्या है 5th के लिए. You are supposed to find out this. What is the forecast for the 5th period? That is what you are supposed to find out. Okay, so just write down this information. If this is not clearly visible, I have already mentioned all that details. So now I will put this information in the tabular form and then we will discuss. Okay, so the same information I'm writing over here now, solution. So he has given you exponential constant as 0.5, and the same data I'm writing over here. Let us say you are having I'm writing something over here so that I can do the calculation over there also. So year he has given you, and you are having demand, and you are having forecast. So I'm writing it over here, somewhere here. Okay, deliberately forecast. So first, second, third, fourth, fifth. What is the demand for this period? Let us say I call this as given to you 200. He has given you 100. He has given you 150, and also over there 250. And forecast for the first period, he's saying is equal to demand in the first period, that is 200. Right? Now you have to find out what is this forecast over here. You have to project for the 5th period based upon the exponential smoothing method. That's all. Now, how you can do this case? You have 2 ways to proceed this by using the exponential smoothing method. One is, since you know the initial data of forecast and demand, you can calculate the forecast for the next period. And for the next period, now you are having demand and forecast. Then based upon that, you can forecast for the next period over here. Same way you can go down till this point. This is one way. Another way is that if you can write it in an expanded form, that means if you can just write in expanded form the forecast for the 5th period, whatever that may be, if you can easily remember, then directly input the data in that, and your job becomes pretty easy. That is another way. So first what I will do, I will go along with your simple understanding one by one in this step, and then finally I will write that formula also, which directly also you can use it, right? So sometimes you forget the formula, at least if you know the basic approach, you can reach that conclusion, so without any much hassle. So what I'm doing is, first of all, how tell me, how do you write the forecast? How do you write the forecast for the next period as per the exponential smoothing method? Forecast for the next period is this one. If I denote it by ft plus 1 is equal to alpha into demand for the previous period plus 1 minus alpha into forecast for the previous period. I hope you understand this. That means if I want to forecast for the, let us say today it's November. So if I want to forecast for the, let us say I will talk this way, December. If I want to forecast for the month of December, then I need to have two information, that what was the forecast for the month of November, a month before that. So t plus 1 December, then ft means November. You need to know how much you had forecasted for the month of November, and for month of November you may have forecasted at the end of October. Like at the end of November I am forecasting for December, same way you may have forecasted at the end of October for the month of November. So you need to have the forecast of the previous period, that is previous to this, that is November. At the same time also need to have how much was the actual demand in November. And actual demand in November, you will come to know how much you actually sold. That will come exactly nowadays, because today is, I think it is 25th. So maybe in 3-4 days at the end of November, you will come to know that how much actually were sold. For example, you projected something. You projected in November, let us say 100. That in December, you projected that 100 will be sold in November. But actually, at the end of November, I will come to know whether I sold 100 or 102, 105, or how much I sold. That is the meaning of this. So this you already know, and alpha is the exponential smoothing constant. So it means when for any particular period, when I want to forecast, then simply I need to have the demand, actual demand, and the forecast data of previous month. That's all, or previous year, or previous period, whatever and you can calculate that. This is one way. So I can use this basic formula, which all of you know over here, and I can forecast for the next period. I can forecast for this period, and then forecast for this period, forecast for this period, and then next period. So I will go ahead as of now with this. So let us say I call this as a demand for the first period, this one, demand for second period, this one, demand for third period, this one, and demand for fourth period, this one. Now I can call it as a forecast for the first period, because he has given that forecast for the first period is equal to demand in the first period. Can I calculate the forecast for the second period? I can calculate, because for the forecast for the second period, I need to know the demand and forecast data of previous period, that is 1 and 1. This information I need to have. So 1, 1, I will have the F2. So input that value, just alpha is given to you. So I can directly take the value. So it will be F2 will be how much? F2 will be alpha into D1 plus 1 minus alpha into F1. That is the meaning of this. So demand F1, you know, alpha, input the value, because 0.5, this is 0.5, this also turned out to 1 minus 0.5 becomes 0.5 only. So that means I will say 0.5 into what is demand for this 200 plus 0.5 into 200. It will turn out to be how much? I think this becomes 200, 100, again it becomes 200. This is the forecast for the second period. Same way you can go for the forecast for the third period. What you need to know? You need to know the demand of previous period previous to this, that is D2 plus 1 minus alpha into F2. So just input that value. What is D2, F2? Do you know? D2 is this, F2 is this. So same way I can find a forecast for the third period. 0.5 into what is demand for is 100 plus, plus 0.5, 1 minus 0.5, 0.5, and what is our forecast for second period? That is 200. So that will become how much? This becomes 100, this will become 50. 100 and this becomes 50, 150. That's all. Same way you can find out the forecast for the fourth period as alpha into D3 plus 1 minus alpha minus into F3. D3, F3, D3, F3, I can find out the forecast for the fourth period, 0.5 into, what is D3? That is 150 plus 1 minus alpha, 0.5 into demand forecast for the, that is 150. How much is that? 150, 75, 75. 75, 75. Something wrong. 150. And was it 150? Okay, so 150, 75, 75, it will turn out to 150 again. Let me cross check if I am not committing the mistake. Yes, 150 is there, right? Yes, correct. Now you are left out with what? I want the focus. Demand I am not bothered about. Actual demand will come. Actual demand I will come to know at later stage. But first we have to focus for the fifth period. So what is that? That I want to find out. F5 I want to find out. So what is F5? You will say F5 will be alpha into D4 plus 1 minus alpha into F4. So how much is that? Simply 0.5. D4 is 250 plus 0.5 into 150 is equal to how much? So it will be 125. Half of this, 125 or iska bhi half hoga, 75, 125 plus 75. This becomes 200. So that means forecast for the fifth period will be simply you have got the this. So that is forecast for fifth period. I can say is going to be, therefore forecast for the fifth period is equal to 200 units. That is going to be my answer. This is one way of doing it, right? Pretty easy, nothing to just simply remember this formula. That's all, your job will be done. Another way is write it in the expanded form. You can write it in the expanded form also. So how you can write? I have to take the fifth period. I have to write it fifth period and go on expanding, and you can write it, you are having this way. So that is, I don't remember exactly, but let me just write it for you. So it will turn out to be alpha into D4 plus alpha into 1 minus alpha D3. So plus alpha into 1 minus alpha square. I think it goes on that way. D2 plus alpha into 1 minus alpha, just one, alpha into 1 minus alpha square, sorry, cube. It will become cube. 1 minus alpha into 1 minus alpha cube D1, and then you are left out, I think, F1 1 minus alpha plus 1 minus alpha 4 F1. So if you will expand it completely by taking a particular period over here, I have taken 5. So this will be, finally I can expand it this form also. So you need to remember. So every time you have to multiply by what? Alpha ko multiply karte jana 1 minus alpha. For example, over here, once you have alpha, then D4, then you will 1 minus alpha, 1 minus alpha, 1 minus alpha. And that final term of initial forecast, you need to have only this one. Alpha will not appear over there. Right? So for example, same way you can write for the F6 also. So alpha into D5 plus alpha minus into 1 minus alpha into D4. Something that way you can expand it. So this is a general form in which you can write. So I have, since I want to find out the forecast for the fifth period, I can write it. Now, if you directly input the values, that's all. I don't need to even find out these values of forecast, this. I don't need to do that. Simply, since I know F1, since I know these demands, see over here, I know D1, D2, D3, D4 given to me. I know the initial forecast, just input it over here directly. Also in one step also I can obtain it. So that is up to you how you want to find out. So if you can easily remember it, then directly go ahead with it. But if you forget it, in any case, this formula, basic formula, you will be remembering in any case, then step by step also immediately. It looks like, okay, it is not lengthy. Immediately you can do it because this is a simple calculation part only, right? That is how you have to proceed. So that is how you can input these values will be equal to 200 units only. You can cross check. That way also you can proceed. Okay, so let us now move ahead to the next question. Just go through it. I think this must be visible. Yes, it is visible, clearly visible. Okay, so go ahead and try to solve it. Okay. Now, if you see in a forecasting model at the end of the 6 month, write this information in a proper way. I think you will get the idea and you will be able to solve it. So, what it says, he has given you the periods 7th, 8th, and 9th. So, what it says at the end of 6 month, he is forecasting for the next period, 7th month. So that means he's talking about the next period, then actual value of 7th, 8th, and 9th period. So he's talking about the next 3 periods, that is the 7th, 8th, 9th. So let us say I'm taking the time, that is the next periods, that is 7th, 8th, and 9th. Okay, these are the 3 periods that he has taken. And what he says, the demand and forecasted value he has given you. What is the actual demand? And what is the forecast? So what it says is that for these periods, actual values mean the demands, actual demands have been given to you, which are 150, 80, and 120. So that is actual demand was 150, then 80 units, and it was 120 units. What was the forecast for the 7th period? So at the end of the 6th month, he forecasted for the 7th month. How much? 100. So that means forecast for this month was 100. Clear? Now, what he's saying? He's asking you to find out the bias. Bias, as you know, is a forecast error. Forecast error, that means to calculate the forecast error, you need to know the demand data, actual demand, as well as the forecast also for that particular period. So, for example, if I'm talking about 7th period, I must know the demand, how much was the actual demand, and how much was the forecast for that period. Only then I can tell that whether there was error or not. Whatever you have forecasted and what it turns out to be actual demand was what? There must have been difference. So there is an error. Same way for the 8th period, what was the actual demand and what was the forecast? So these two information you need to have. But this information we don't know. Forecast for the 8th and 9th period, for which he has given you the exponential smoothing constant alpha, which is equal to 0.5. So it means on the similar lines as we had in the last question, I need to find out the forecast for this period also. What? 8th and 9th period. So how I can find? I can find it very easily. So simply I need to have a forecast for the I will not write over here, I will write directly over here. So forecast for the 8th period will be equal to alpha 0.5 into demand for the 7th period 150 plus 1 minus alpha 0.5 into forecast for the previous period 100. So it will turn out to be how much? 75 or 50? 125. 50 and 0.7. Okay. Now, what about the forecast for the 9th period? 0.5 into 80 plus 0.5 into 125. So this will turn out to be 40 plus 125 ka half aapka. So this value will be how much? 102.5. ये वैल्यू आ गई आपकी. That's all, my job is done. अब मुझे क्या चाहिए? I want to find out the bias. Bias कैसे find out करते हो आप? First, I need to know bias. Bias, how do you know? So bias is simply the difference in the di minus fi. In general form, this is how you write. The difference, these are the 3 periods given to me, And for these periods, I want to add the difference of these values, this, and divided by n, number of observation, 1, 2, 3, and I from 1 to n. N means how many observation. So for first observation, this summation of these, difference of this, plus second observation, difference of this, third observation, difference of this, divided by number of observation, that is 3. So simply now, what you need to do is write it this way. In expanded form, I can write this. So let us say, I will say this is the forecast for 7th period. And if I say this is demand for 7th period, demand for 8th period, or 8th month, demand for 9th period. Simply take the difference and add them. That's all. Nothing special in it. So D7 demand minus forecast. Demand for 7th period minus forecast for this becomes a forecast error. So I don't have to take the mode, I don't have to take the square, simply the difference and add them up. Plus demand for 6th period, sorry, it's 8th. Demand for 8th minus forecast for 8th. What was the difference between this and this? Plus what was the demand in 9th period minus forecast for 9th period. Divided by how many observation? 3 observations. Now see the difference. Write down those values. 150 minus 100, this minus this, 50. So should I write it directly? 150 minus 100 plus 80 minus 125 plus D9, 120 minus 102.5 divided by 3. What is this value? So you see, it will, whatever the value, because here you are having negative, this is plus, plus overall value will turn out to be, I think, positive, and this turns out to be 7.5. Now based upon this value, whether this value is positive or negative, you have to decide whether that bias is overestimation, that bias indicates overestimation or underestimation, or what. Now, what is the meaning of overestimation and underestimation? If I simply say, let's say, forget about this kind of total values that we are calculating over here. Let's simply say I take one value only, this one. I'm taking the difference. This was simply the difference of a summation of all the differences in all these values. So if I say this difference, let us take. For this period, 7th period, your forecast was 100 units, whereas demand was 150. Now, if I ask you, was it your estimation or underestimation? You will say, you had forecasted 100, but actual units sold were more than that. Actual number of units sold were more than whatever you have forecasted. It means what you had done, you had underestimated. What you had underestimated? You had underestimated the demand. Right? That is the meaning. Underestimation and overestimation meaning is that we are talking about the demand which we want to forecast. So if our forecast is less than the demand, so we underestimated it. In this case, I forecasted only 100, but actually it was, on units was sold were 150. It means I had underestimated. That is the meaning. So here, if the value will be, let us say, positive, this will be positive. This difference will be positive. So even if it means when this value will this difference will turn out to be positive, it means it will be underestimation. What is the meaning of that? It means if this difference will be positive, it means forecast value will be less than the actual demand. If forecast value is less than the actual demand, it means you had forecasted less. If you had forecasted less, it means it was underestimation. As simple as that. So in case of underestimation, this D and F difference will be positive. So same way, in this case, let us say specifically only if I talk about this only. Now tell me, for the 8th period, was it underestimation or overestimation? You will say, in this case, you have overestimated. Actual demand was 180, but you forecasted 125. So you have overestimated. So if I have overestimated, what is the difference of D and F? It is negative. 80 minus 125. It means if the difference coming out to be negative, it means I have overestimated, because in that case, forecast will be more than demand, actual demand. Those I have overestimated. What I have overestimated, overestimated the demand. That is meaning. So it means same interpretation goes to this overall value, simply overall. So this will give you the holistic idea of all these demand and forecast figures. So in this case, if the value will turn out to be positive, it means demand must have been more than forecast, only then this value, overall demand of all these periods. This is how you have to interpret. Must have been more than forecast. If overall demand must have been more than forecast, it means you had underestimated because forecast was less. So you must have underestimated. Only then this value, overall forecast value must have been less than the demand value. So you have underestimated. So positive, it means it was underestimation. So my answer is going to be B. So positive, underestimation. If bias is positive, underestimation. If bias is negative, it means overestimation. It means value will negative. It means overall forecast must have been more. So you have overestimated in that case. That is how you have to interpret. Okay. So now let's go to the next one. Just go through it. This is a break-even analysis. This question is based on break-even analysis. Now, I don't know how many of you have heard this term, but if you have heard, you will be able to do. If you have not heard, simply you will not be able to do. Right? So what it says, break-even analysis, at one end it is cost, at other end you have this okay, so one is a fixed cost. For example, that remains fixed. I can take any particular color. I will take this one. That with the volume of production, as you go on increasing the quantity, how it affects the cost part. So this one is this fixed cost, let us say, and then you are having the variable cost, which I show you. If I show you this way, so if I want to show the total cost, add them up. This is fixed cost, this is variable cost, this is fixed cost. If you will add them up, you're going to have this one parallel line will go over here. So this is going to be the total cost. And obviously when you will sold, you have produced this component, you have the cost involved. Total cost will be this one as per this analysis. At the same time you are selling this particular product, then obviously you are going to have sales price involved also, something this way. So this is the revenue, we call it as a revenue or total income, whatever you want to call it, revenue, total revenue. And this point correspond to break-even quantity, BEQ, right? This is what you have. In terms of number of units, this is, and in terms of price, if you want to write it, you can write it this way. So now, what it says that he's asking us to calculate the contribution. Now, term contribution should be clear to you. Contribution is so you have contribution equal to total sales minus, okay, I need to write down the information also. I will write it down there. Okay, so I will write it, contribution equal to total sales minus total variable cost. Okay, what does that mean? For example, if anywhere I'm if I take any particular line, let us say if I'm over here anywhere, so corresponding to this quantity, if I ask you what is the total sales that you made, and sales price, how do we denote? We denote with this help of this. S is the sales price per unit. I think sales price per unit for the product he has given you, the rupees 100 per unit. Same way, he must have given you the variable cost per unit. We denote it by small v. How much is that? Variable cost per unit is rupees 80 per unit. Right, and fixed cost anyway we denote with this, that is rupees 10,000. The contribution and profit and all that this, and what is the profit for the sales volume of this? Sales volume mean how much units you are selling. So that's any particular quantity Q that we are talking about. So sales volume mean quantity that you are selling, that is 50,000 units. We denote it with units. Now, when we say total sales, let us say if you are producing quantity Q over here, how much in terms of rupees you sold? You will say Q you produced, if you multiply it by the sales price per unit, you're going to get this point. It means this whole of these lines of total revenue or total sales is sales price per unit multiplied by how many units you sold. So depending on if less number of units you are selling, sales price is going to remain constant. So simply these different points you are going to get, you are having this line. So this is the total sales line, SQ, sales price per unit multiplied number of units you are producing. Let us say. Same way on the variable cost, you have the same situation. For example, we have the variable cost this way. So I am producing this much Q quantity, and if I multiply by the variable cost per unit, then this is going to give me the total variable cost. So this line basically represent the variable cost per unit multiplied by number of units that you are producing. Total cost, simply this plus this becomes this, whatever point that I am going to have. So over here. So total cost point is this, corresponding to the quantity Q that I am producing. Variable cost point is over here, this one, right? And fixed cost you already know. That is how it is. Now, what do we say is contribution is the total sales minus total variable cost. So total sales is how much? This much. And total variable cost is how much? This much. So if you will, from this, if you reduce total variable cost, then you are going to have this minus total variable cost. This will give me this difference, SQ minus VQ, from here to here. From here to here, this will give me the contribution. Okay, so that means total sales kitni hogi? Total sales means total revenue, total income, whatever you want to call it. So that is the S, sales price per unit multiplied by quantity sold, minus variable cost per unit multiplied by number of units that you sold. So this becomes Q into V, S minus V. So this will turn out to be in rupees, unity rupees. So S into, sorry, Q into S minus V. Now, I think I don't need to explain it in detail, what is the meaning of contribution, but normally when we study about this diagram, then contribution we refer to that how much you are contributing toward offsetting the fixed cost, right? It is not the profit. Keep it in mind. When we say total sales minus total cost, so this portion is profit. We call this profit. Total sales minus total cost. You will say this much is the profit over here. But when I say this minus this on this particular line, then we say this is the contribution. So contribution, if you want to have in mind, just keep it in mind. We are normally referring to this quantity will, if it is large, then we can offset the fixed cost easily, because that always is going to incur, because without that you cannot survive if you have invested in the plant, etc. So larger this proportion, it means fixed portion can be easily offset, and you are more towards the profit, in the direction of profit, something that way you have to interpret. Now simply just input the value. Q is how much? 50,000 units into sales price per unit 100 minus variable cost per unit is this much. So total turns out to be in this. How much is that? So it will turn out to be 1,000 rupees. This much. 10 lakhs. It becomes 10 lakhs. So this much is the contribution that you can find out. So remember this term, even if you are not very pretty clear about it. So he may frame the question directly. Then you have profit volume ratio. Now, profit volume ratio also, PV ratio also we call it. So profit volume ratio, basically it is a ratio of this contribution to the total sales. Contribution to the total sales. Now over here, sometimes you have a confusion in terms of profit volume ratio. That means you may think that this is a ratio of profit over volume. Volume, okay, you can interpret that volume of goods sold. How many units you sold in terms of price. So that becomes simply the total sales. So maybe if you talk this way, profit over volume. Let's say this is how we call it, right? So profit volume ratio. So we have tendency to interpret this term this way, that it must have been the ratio of profit over the volume. Volume, which you can interpret that this much quantity I sold, and if I multiply by the sales price, so this becomes the total sale SQ. That you may be somehow link. But profit, you are not able to link that. In the formula, you will say that no, you are not writing profit over here. That is why I explained you over here that contribution, larger is margin, this difference, more it is going to contribute towards the fixed cost, and therefore you are more towards the profit side. There is a high probability of getting the profit. So I want more contribution. So more the contribution, I will have more contribution towards the profit as well. That is how you have to interpret. So when we talk about this ratio, don't interpret this ratio literally, that it must have been the ratio of profit over volume. No, you interpret it that in terms of contribution. So more is the contribution, more it may have contributed towards the profit. That is how you have to interpret. So you can remember that way easily. So now if that be the case, then I think contribution is, in terms of rupees. So I have to write this in terms of rupees also. So, or you can may write that way also, this divided by S into Q, or also if you want to write other way around also, then contribution is how you have written SQ into S minus V divided by S into Q, total sales. QQ will cancel out, S minus V divided by S. S is 100 minus 80 divided by 100. 20.2. This becomes my answer. So one is this and this. Okay, so that is how you have to. So keep it in mind. This could be the some question. ये आपके लिए surprise हो सकता है, in the sense normally when we discuss this topic, हम बहुत ज़्यादा डिटेल में जाते नहीं है. Particularly contribution term हम हमारा appear होता है. Normally when you are in kind of that commerce side of that particular this commerce में जो लोग जब break even analysis discuss करते हैं ना, so they have this term appearing contribution, and वहां पर थोड़ी सी डिटेल में हम explanation भी दे देते हैं कई बार. पर engineering when we talk about in engineering, so we normally don't talk about the contribution term कि क्या है, जबकि हमने break even, whereas we have studied this in detail, but we don't talk about this. Same way PV ratio हम discuss कर लेते हैं, but PV ratio में भी हम क्या करते हैं, we talk about the formula directly. बट जब हम उसको इंटरप्रीट करने चलते हैं फॉर्मूला को, पीवी रेशियो को, देखो सी हाउ द एनोमलीज. ये हम पीवी रेशियो डिस्कस करते हैं इन इंजीनियरिंग, बट डायरेक्टली इन टर्म्स ऑफ फॉर्मूला. जब हम फॉर्मूला के टर्म में रिलेट करना चाहते हैं तो हम समझ नहीं पाते हैं उसको कि व्हाट इज द मीनिंग ऑफ दैट प्रॉफिट वॉल्यूम रेशियो. But that profit volume ratio has come from this. Once you have defined contribution, then only you can write. So it is very important for us that अगर मैं PV ratio को, when I am talking about the PV ratio in engineering, and I am not understanding that, so I should understand that from where that ratio is coming, then definitely contribution term is going to appear. So if definitely contribution term is going to appear, you must know what is the contribution. That is how you can relate. Okay. Let's go to the next. Okay, you must be able to solve it. Okay, so just go through it. So annual demand of rivets at a ship manufacturing company is this much, and the rivets are supplied at a units of this. आपको कॉस्ट दी हुई है, ऑर्डरिंग कॉस्ट, कैरिंग कॉस्ट भी दी हुई है, एंड परचेज कॉस्ट, these values have been given to you, right? So now in this case, nowhere he is talking about the what? प्रोडक्शन रेट, कंजम्पशन रेट. कंजम्पशन रेट तो डेफिनेटली वी नो यूनिफॉर्म कंजम्पशन है, तो एनुअल डिमांड वहां से आ सकती है. प्रोडक्शन रेट ही इज नॉट टॉकिंग अबाउट. ही इज नॉट टॉकिंग अबाउट द प्रोडक्शन रेट, नाइदर ही इज टॉकिंग अबाउट द शॉर्टेज. इट मींस definitely this model must be infinite production rate, this one, simple EOQ model. And when you have the simple EOQ model, it means you already know what we have to find out, the length, cycle length of the order. Cycle length मुझे निकालनी है ये. And if I want to find out the cycle length, for me, I must know what is the order quantity. And since I have not been given the order quantity, how much quantity should I order each time, then I must find out that quantity which will optimize or reduce the total cost. So for that, I must order Q star. So it means over here, first I need to find out the quantity that I should order, which we call it as the economic order quantity. And you know, in case of simple economic order quantity model, you are having this. And for that, simply you are having demand. Annual requirement of rivets is 2000 kg. He is saying 2000 kg मुझे साल में चाहिए. At the same time, he says that I will take in the form of 1 kg packets. Right? It means how many units are there? So 1 kg packet will become 1 unit. So it means annual demand will become how many units? You will say 2000 units. Because each unit will be of 2000. Each unit will be of 1 kg. Okay, that is how you have to interpret. And what is the cost of each unit of 1 kg unit? You will say this is the actual cost of that particular one packet of 1 kg will be equal to how much is that? 1 kg consisting of 25 each. That means iski jo hai wo 25 rupees 25. So that means actual cost is rupees 25 per unit. And what is the carrying cost? If it costs 100 to place an order, so ordering cost he has clearly given to you, 100 rupees per order. At the same time, he has given you the carrying cost. How much is the carrying cost? He's saying 9% of his purchase cost. So purchase cost is how much? 25 per unit. So now, since annual cost of carrying, that means he has given you the rupees 9% of this, but that cost that you are coming out to be rupees per unit per year. That means उस यूनिट को, एक यूनिट को कैरी करने के लिए, to carry 1 unit for a year, how much is the cost involved? He's saying that is 9% of this. It means when I will take 9% of this unit cost or the purchase cost, that will be 9% means 0.09 multiplied by 25. This will become rupees, this much rupees to carry each unit for the whole year, that is per annum. That he has very clearly given. That's all. Now, if that be the correct, then correct interpretation. Rest is just you have to input the value. So how much is that? You are going to say demand, annual demand 2000 units, ordering cost 100 rupees per order, carrying cost, if you are taking in, this is annual, so keep it in mind, this is units per year. So if I'm taking annual demand, this demand as annual, then over here carrying cost I have to take in year only. So over there I'm having 0.09 into 25. And what is that value? So economic order quantity that you have to, there is 421.63 unit. That means each time you have to place an order of 421.63 units. If that be the case, then you know time if you are placing Q star, then this time will be T star. So how much is that? Number of orders that you have placed, optimum number of orders that you will place in that particular year. So you will say that is demand by Q star. So Q star will go up. So that means what is Q star? Q star you have 421.63 and demand, and he has asked you in days. So that means demand you have to write in days. So this is per year, 2000 per year. So convert that year into days. So since he has not mentioned how many working days and all that, so I have to take the 365 days in a year in that case. So simply 365. So this total value will turn out to be in days. That this will become the cycle time, 77.015 days. So ये जो cycle time है, that will become the this much. That is how you have to interpret. So take care of the units that you are going to input over here and synchronize those values properly over here, and then input directly over there, and you can get the desired result. Okay, so that is all that we have today, and see you in the next session. Maybe one more session I will be taking on the industrial engineering portion. So see you then. For today, that's all. Thank you very much and good night.